Okay, let's get started with trig identities. So you're proving trig identities, and you've seen trig identities before, such as, but these are very simple ones. Secant of x is the same thing as 1 over cosine of x, meaning that it's just cosine and it's the reciprocal of it. Cosecant is 1 over sine. Cotangent is 1 over tangent. You've shown that, we've talked about that tangent is the same thing as sine over cosine. So what we're going to do is some more trig identities, and these are a little more complicated, and there's 3 of them that we're going to do, and the first one is right here, this one right here, which is reading sine squared of x, or sine of x squared. Another way you might see that might be sine of x squared plus cosine of x squared equals 1. Notice that 2, this is where math is a little interesting, or like the math language in the community is a little interesting, because they like to put the 2 sometimes right here, meaning the squared. So it looks like you're just squaring the sin, but really you're squaring everything. I guess it just makes it look really fancy. So if you see that 2 and it's in between the cosine and the x, just know that really what it's saying is this, okay? That's really what it's saying. It's saying sine of x all squared, cosine of x all squared. Okay, so what we're going to prove is that if I take sine of x and I square, and I add cosine of x squared, I will get 1. That's what I want to prove to you. And to start there, I just want you to see that it looks a lot like Pythagorean theorem. A squared plus b squared equals c squared. So our end goal is to get sine of x squared plus cosine of x squared equals 1. To do that, I want to assume the Pythagorean theorem, and then I'm going to create just a right triangle to help me show it. So this isn't really a formal proof, okay, because I'm using a picture to help, but it is proving the concept here. So to start, just notice that the angle I'm referring to is this x. So now I'm going to use my trig ratios. So if I were to ask you to find for me what sine of x would equal, remember that is opposite over hypotenuse, so this would be a over c. If I asked you what cosine was of that angle, it would be the adjacent, which is b over c, which is your hypotenuse. Okay? So what I'm going to do, in a sense, is I'm going to replace the sides a and b with sine. To do that, I need to solve for a. So notice I will multiply this by c, the hypotenuse over here. I'll multiply this by c over here. And now I have a new statement. I have a equals c times sine of x. And the other one is b equals c times cosine of x. Now that I know what a and b equal, I'm just going to replace a with this, c times sine of x. So now I have c times sine of x, little parenthesis here, all squared. And I'll replace b with this, c times cosine of x, all squared. And this all has to equal c squared. So now if I continue with this, I will square everything. So notice since there's no addition here, there's no issues with me doing c squared times sine of x squared. I'm going to put the 2 here, just so that way you guys start feeling a little more comfortable with that. Plus c squared times cosine squared of x. Okay. And now notice there's a c squared on each term. So what I can do is I can divide out c squared. So if I divide out c squared, divide this by c squared, divide this by c squared, and this by c squared, I'll end up with my trig identity, which is sine of x squared plus cosine of x squared has to equal 1. And this right here is your trig identity. So that trig identity will pop up a lot in pre-calculus and in calculus. It is used. So this is something that's valuable and using it for the next few classes. So that is your trig identity. So here's the cool part. There are actually two others. And the two others happen to be the same thing as this. They're pretty much equivalent. All that I'm going to do is just rearrange just a little bit. So the first one is 1 plus tangent of the angle. I'll just say x. It could be of theta. 1 plus tangent of square root of x has to equal secant of the angle squared. There's another one. And finally, the other one is 1 plus cotangent square root of x. Or here, let me backtrack. I was using theta. Let me just stick to the same. Of x equals cosecant of x. Okay? So here are your three trig identities. And they are all pretty much the same. They're just rearrangements of each other. Identities. I think it's this. I'm just going to say ID. Okay? Sorry, I'm writing this and I'm pretty tired already. So, that right there are your three trig identities. You can memorize them? Sure. But you should be able to recognize it. And the way to get these other two, it's actually pretty simple. I'm going to always start with this, and then I'll work my way here. So if I look, notice, how do I get that first trig identity to match the second one here? Just want to kind of pick your brain for a second. Notice there's a 1 here. Okay. So, and then there's a tangent squared. So what can I do to this to get tangent? Let's just think about that for a second. How do we get tangent? Well, since you have sine and you have cosine, I could divide by either sine or cosine. Now, here's the key part. If I divide by cosine, notice what happens to this trig identity there. If I divide by cosine, you get sine, I'll write it this way, sine of x squared all over cosine of x squared. If I divide by cosine to the other piece, I just get 1. And then divide by cosine squared, I get 1 over cosine of x squared. Notice this right here is really just tangent of x squared. So I'm going to put the 2 here. Plus 1 equals, this is just secant of x squared. So here's your second trig identity. All I did was, I wanted to get to tangent, and I noticed, hey, if I just divide by cosine of x squared, I get to tangent. So, I think I messed up over here. Yes, I think I said cotangent, but I put cosine. Excuse me, I didn't catch that for this one. Okay, sorry. So that's how I got my second one, is I just divided by cosine squared. Now, what if I wanted to get cotangent? What if I wanted to get cotangent? Instead of dividing by cosine, what if I divided the first trig identity by sine? So if I do that, notice you would get sine of x all squared over sine of x squared plus cosine of x squared divided by sine of x squared. And then you get 1 over sine of x squared, which is just cosecant squared of x. So what I wanted to show you in this little video was pretty much there's only one trig identity you need to know, because you can get the other two by dividing out sine or dividing out cosine. So if you forget, I would start here This one's pretty easy to remember because it's a lot like Pythagorean theorem. Then if you're like, oh, what was the one with tangent? Okay, I need to get sine over cosine to get tangent, so I will divide by cosine squared of x. And then, voila, you'll have everything. Oh, how do I get the one to be cotangent? That needs to be cosine over sine, so that means I need to divide by sine. So if I divide by sine, I will get cosine over sine, which is cotangent. Okay, so really there's only one trig identity you need to understand, and that is this one. Okay, so what you're going to be doing is you're proving trig identities. So you're going to use those three to prove. And let me give you just a few examples for you to try. Okay. So in order to prove officially, what's going to happen is it'll be something like this. It'll say, hey, prove, and it'll show you. It'll say prove, and then it'll give you a statement. So here, let me write up the statement. Prove sine of x times secant of x equals tangent of x. So if I'm asking you to prove that, what you're going to need to do is show it. So I will start with this statement. Okay. I don't want to start with the final statement. This is what I'm trying to show. So I will start with, here, I'll write sine of x times secant of x. And I'll say this equals, and now what I will do is I can just go through and, actually let me backtrack. There you go. I will start with my proof statement right there. I'll just leave it as is, and then I'll put equals. So if I look at sine of x times secant of x, really I see sine of x times 1 over cosine of x. Or in other words, this is just sine of x divided by cosine of x, which equals tangent of x. And since that's what tangent of x equals, that's my work. I've just shown that sine of x times secant of x basically is tangent of x. Okay. Now, there's a very precise way of doing this. Basically, you don't want to mix up your equal signs in a sense. So once I have my statement, there it is, I will proceed to it until I arrive at my final destination here. So I start, in a sense, with what I want to show, and then I show how I get from this piece down to the end piece. So you start with what you're wanting to show, what you're trying to prove, and then you're working your way until you arrive at the desired result. So here, let's do another one. So I'm asking you to prove tangent of x plus cosine of x all over sine of x. Prove that this equals secant of x plus cotangent of x. Okay, so that's what I want to show. So to start, I will keep this statement here, and that's what I'm going to work off of. Okay, so here we get going. So the first thing I will do is I will actually put that down again. So I'll put down tangent. Oh, go back. I'll put down tangent of x plus cosine of x all over sine of x. And I'll say, alright, what does that equal? Well, if you take a look, how could you rearrange some of that? What could you do? Well, first thing I see is, since I'm divided by sine, I can divide each piece by sine. So I will split it. I'll write this as tangent of x divided by sine of x plus cosine of x divided by sine of x. Okay? So I've just done one piece. I don't know if it's going to work. I'm just going to go with it. So now, what do you notice? That's the next part is, okay, so here I am. What can I do? What do I know about, can I do anything with cosine and sine? Well, you might recognize, hey, isn't that just cotangent? Because cotangent is cosine over sine. So therefore, what I could do is my next statement, I could just include this as cotangent of x. I can just put that down. I left this blank on purpose because just in case you wanted to do anything, you could just write tangent of x over sine if you wanted to, or if you wanted to rewrite this somehow, you have opportunity to do it. So if I look, tangent of x over sine of x, I recognize that tangent is sine of x over cosine of x, and I'm dividing it by sine of x, which over to my side, I just want to point out that that's the same thing as saying this, which means the sine of x's cancel. So my next statement is going to be, hey, this is really just 1 over cosine of x plus cotangent of x. Okay. Which then, my final statement will be, well, that's just really secant. So this is equal to secant of x plus cotangent of x. So notice that was my desired result, which matches what I had up here. And I'm finished. So a few things to take note of, just to help you with the whole process, is there's this logical flow statement. Each statement, in a sense, is lined up with the equal sign. So I don't have to, if I were to do this really formally, I have to write that here and that there, and basically have to write this each time. But since it's the same statement, I can do a little shortcut and just say, hey, the left side is always going to be this statement, so I'll leave a blank, but the equal signs are all lined up, and I'll work my way down. So you don't want to jump too quickly with your logical statements. You want to show, like, how did I go from there to there, from each statement. Or a short way of saying it would be, make sure your equal signs are lined up, okay? And that after each statement, you've got the change, and it's pretty well noted what you did, okay? So let's look at another one, okay? These they're kind of like a puzzle, to be honest. They are kind of like a puzzle, so let's try another one. So here, let's prove cosine of x over 1 minus sine of x is the same thing as 1 plus sine of x over cosine of x. Okay? So, taking a look at it, I will start my proof by putting down cosine, what's on the left side, over 1 minus sine of x. I'll put that on the left side. And I got to figure out how am I going to change it. What am I going to do? Well, notice there's this 1 minus sine of x, right? I don't necessarily like the 1 minus sine of x. I wonder if there's a way we can, in a sense, get rid of it. And so what I think I'm going to try and do is I will take the 1 minus sine of x and I'm going to multiply by its conjugate, which is 1 plus sine of x. 1 plus sine of x. And the reason is, if I multiply by its conjugate, then the middle term will go away. And what will happen, and just thinking kind of ahead, is my next statement right here is going to be cosine of x up here times 1 plus sine of x all over 1 times 1 is 1 squared. That is negative sine x squared. Oh, here, let me do this properly. 1 times 1 is 1 squared, 1 times sine is sine, but then if I multiply here, notice it's negative sine of x, so that will cancel. And then I will end up with negative sine of x squared. So I'm at this statement right now. So notice, now the question is, well, what can you do? Well, 1 squared is just 1, so I actually don't need that there. And now I can take a look and be like, all right, I have no idea where to go from here. But I do want to point out, notice there's this sine squared of x, and here's this 1. Think back to the original, the first trig identity. Is there any way you could rearrange this trig identity, to get it to be 1 minus sine of x squared? And the answer is yes, I can. So I can minus the sine of x squared over And here's my statement. Cosine of x squared is the same thing as this, 1 minus sine of x squared. So I can replace it. I don't necessarily have to have this work here. Okay? I don't need to show that. But what I will do is I will just replace that denominator with cosine of x squared. And then, notice, oh, the cosines will cancel, and then you're left with 1 plus sine of x all over cosine of x. Which, if we look, that is what the statement we wanted to end with. And I am finished. Okay? So, again, it may look really confusing because you're like, I don't know how to get there from there. So you just kind of keep moving, do something, try and rearrange something. So let's look at another one and give you a chance to try it out. Okay. So here, this is what you're being asked to prove. So we want to end up with this. Okay. And if you're not sure where to go from there, then just start with the left side. Okay. Notice we have a 1 minus sine of theta up top. We can try and multiply by conjugate, but and see what happens there. Or if I see there's a denominator and I see there's a secant here. Oh, excuse me. Part of me sees that, hey, I can just divide each of those pieces on top by cosine of x. So I will rewrite it as 1 over cosine of theta minus sine of theta over cosine of theta. And now notice 1 over cosine of theta is really just secant of theta. This is really just negative tangent of theta. And look, hey, that's what we wanted to prove. So we're done. So sometimes you get really lucky. Other times it might be a little more of a challenge. So here, I want to do another one. And hopefully you're starting to see kind of an idea of what to do. So here I have sine of x plus cosine of x all divided by sine minus cosine of x minus sine of x all over cosine of x. And this is asking me to prove that this is secant of x times cosecant of x. Okay? So take a look. What might be one thing that you could do? So just for the sake of time, I'm just going to say that statement, this entire statement is just right below. Okay? So now if I'm looking there, I see, hey, I can divide each piece by sine for this first piece. So this would be 1 plus cosine of x over sine. I notice for this, I can divide each piece by cosine. So it would be 1 minus sine of x over cosine, but because of this negative, I'm going to write it as negative 1. I'll distribute. Plus sine of x over cosine of x. And now I'll take a look and see what can I do now. So I see, hey, this negative 1 and this 1, those will cancel. And then I'm left with cosine of x over sine of x plus sine of x over cosine of x. Okay? So now I'm going to take a look and there's some interesting things happening here. And I'm trying to get to this statement where it's secant of x over cosecant of x. Or I'll just make a little note that says 1 over cosine of x times 1 over sine of x. Okay. So it looks like I need to have cosine on the bottom and sine on the bottom. Alright. So if I'm not sure how to get there to here, meaning here to there, I'm just going to see, hey, I have an addition sign. There's no addition sign here. So what if I were to add those? To add them, I'd have to get the same denominator. So that means I'd multiply the left piece by cosine. So I have cosine of x squared over sine of x times cosine of x. Okay. And then if I have to multiply this piece here by sine of x. So this would be plus sine of x squared. And now I have a common denominator, so I can add them. So notice I have this next statement, cosine of x squared plus sine of x squared. So you should recognize that this is your trig identity. We know sine of x squared plus cosine of x squared is really 1. So my next statement is just really, this is 1 over sine of x times cosine of x, which is the same thing as saying 1 over cosecant of x times 1 over secant of x, which is the same statement. Actually, whoa, kind of jumped ahead and I messed up. 1 over sine of x times 1 over cosine of x. There we go. This is the same thing as saying cosecant of x times secant of x. There we go. Okay, and that matches what we had up there. So, my recommendations when you're solving these is just start by trying to manipulate the left side. Manipulate. How do you spell manipulate? Manipulate the left side. Here are just some strategies. Manipulate the left side. See if you can rearrange things. See if you can try and adapt it. And just kind of simplify it as you go. 2. Another thing is, remember you have those 3 trig identities. You have the sine of x squared plus cosine of x squared equals 1. You have the tangent of x squared plus, here, let me make it very obvious what this is, okay? Squared plus 1 equal to secant of x all squared. And finally you have the other one, okay? These can be used to help you simplify. So remember, the examples I did with you, I only used the first one. So for example, here I used the first trig identity. And if I look at another one, I think I used it, yeah, right here. Okay. So just know that you may need to use those trig identities to help you simplify it down. Okay. Notice it was really easy to think of this as sine and cosine. If I can rearrange and rewrite it as sine, so if I see a secant, I'll put it as 1 over cosine. If I see a cosecant, then I'll put it at 1 over sine. So it's really easy to work with sine and cosine. So try and rewrite the trig identities as sine and cosine. Okay? And don't forget about conjugates. Remember, conjugates are simply like 1 plus sine of x. Conjugate of that would be 1 minus sine of x. Because you multiply those together, the middles cancel. What's really nice is then you have the statement 1 minus sine of x squared. And that is something to use. Okay? So don't forget about conjugates. And then also just keep trying. Try and do something step by step. See if you can work it around. So the last thing I want to do with you, I know this video is already going quite long. I appreciate you sticking with it. But let's do one more, and then give you a chance to start the next one. So I want you to prove this: cosine of x squared minus sine of x squared has to equal cosine squared. Oh, I forgot this part. That has to be divided by 1 minus tangent of x squared. So, just for simplicity, I just want to say I'm going to rewrite that here. I would rewrite it there. So now I'm going to look and see, can I rearrange anything? Can I manipulate anything? And the top almost looks like the first trig identity, but notice there's a subtraction. So unfortunately, I can't do anything with that. However, if I look, that bottom piece, meaning the 1 minus tangent of x squared, that looks a lot like the second trig identity. Oh wait, which one is it? Almost looks like, yeah, almost did. So now it's like, oh shoot, what do I do, you know? What can I do? One moment. So what I could do is I look and see, I can't use any trig identity. I could try and put replace tangent sine of x squared over cosine of x squared. Might be tough. Or I can recognize, hey, what if I were to multiply by 1 plus tangent of x squared? What would happen there? Maybe give that a shot and see. Okay, notice I'm just throwing things out right now. So if you were to multiply by the conjugate here, just think about what might happen. It might get really tedious because now you have a tangent to the fourth power here, and that might just be way beyond what you might want to do. So then I'll try trig identities. I'll try that. I'll be like, alright, so what if I replace cosine squared of x with the 1 minus sine squared of x? What if I do that? And see where that goes. Oh, maybe, and that doesn't actually go anywhere if you tried it. Alright, so then I'm like, I'm really struggling here. I'm not totally sure what's going on. So again, I'm going to look back at my strategies. We're kind of here. It's like, okay, try manipulating and see what I can do. That's what I'm trying to find out. I'm stuck. I don't see how to make any of those trig identities work. Maybe I'll try and rewrite things as sine and cosine. So let me try that. The only one I can do is that bottom piece. So that bottom piece is really 1 minus sine squared of x over cosine squared of x, which I'm not sure what might happen there, but if I see there's that 1 in there, and so now I'm kind of at this point where I'm trying to think about what I could do, and the only thing I can think of at the moment would be, how do I get this down to cosine of x squared? But looking at it, what if I were to try and just combine the denominator to 1? To do that, what if I rewrite 1 as cosine squared of x? If I do that, I see something. Specifically, then now that I have a common denominator, which is right there, I have something to work with now. Maybe you don't see it, but those are going to cancel each other out. And notice what I'm trying to demonstrate here is it's not going to be as clear cut as maybe how I was presenting it earlier. I wanted you to see me struggle because I deliberately chose this one because I didn't do it yet, and so I wanted you to see that the struggle is real, guys. Maybe you already knew the struggle was real in this class, but the struggle is real because it's not going to be clear cut. You're going to hit some roadblocks. You're not going to know exactly what to do. And that's okay. You just got to keep trying something and see if it works. I tried two different things before and it wasn't working for me. So then I was like, all right, let me try another strategy. Let me put it as sine and cosine, and that's when something clicked. So sometimes you'll go through 3 attempts. So now notice that this right here will be divided out by that. Because really, if I'm dividing by this fraction, I multiply by its reciprocal. So that's what I've done here. So now those will cancel, and I'm left with cosine of x squared. Okay? Which is what I wanted at the beginning. So again, notice my equations are lined up. I was lazy. I did not write the left piece here. You need to write the left piece here. Don't follow my example. But then notice the equal signs are all lined up. Each step you can see kind of a logical progression. That's kind of it. So, in summary, a lot of things happening. Use these trig identities as needed, and you're going to get stuck, guaranteed. But keep trying something. If I were to put a 5th one, keep trying something. These are like puzzles. Okay, keep trying something, because if you're stuck, try a different strategy. Can I use a trig identity? Can I rewrite sine as cosine? Is it a conjugate? Okay, keep trying something. All right, best of luck.